After running our 4.6 liter 4-valve intake test, all the 5.4 guys asked the same thing. Hey, what about us? We want an intake shootout. Well, let's see if you deserve one. How many of you 5.4 guys know what a Boss 290 intake is? All the guys from Australia. I got my hands up. They all know, but I tested that unicorn, a Boss 290 intake on a 5.4 liter 4-valve along with a lot of other intakes. Let's check it out. In this video, we're going to take a look at an intake shootout I ran on a 5.4 liter 4-valve Navigator motor. And when I say Navigator motor, I actually mean it's a modified Navigator motor from Sean Highland. It had 10-to-1 compression, it had ported heads, and it had cams in it, so it was a good test motor. But I ran a number of different intake manifolds. I ran the factory Navigator intake, I ran a modified Navigator intake manifold, I ran the Boss 290 from Down Under, I ran a Sullivan single plane intake, and as always, I ran my Super Richie fabricated adjustable intake. Lots of stuff to do. Let's get going. As I mentioned in the introduction, not only did I run the big intake test on the 4.6 liter 4-valve motor, I also ran this test on a 5.4 liter 4-valve, and honestly, I've also run intake tests on 2-valve stuff and 3-valve stuff, and even the early B-headed 96 to 98 4.6 liter 4-valve stuff. So this is the test on the 5.4 liter 4-valve stuff, and naturally we started out with a Navigator intake because that was the factory intake on a 5.4 liter 4-valve, but our test motor came from Sean Highland, and it was a modified 5.4 liter. It had ported Navigator heads. It had stage 2 and 3, a combination of stage 2 and 3 cams, 2 on the intake, 3 on the exhaust. As I said, ported heads. It also had 10-to-1 compression. We ran it with Hooker long tube headers. It had 65-pound injectors, a fast XFI management system, and we ran all of this testing on 91 octane. And obviously, we adjusted the timing and airfield to try to optimize each one of these combinations. The one thing that I wish I would have done that I didn't do in this is I wish I would have ran a little bit more engine speed. I wish we would have ran some of these things out to 7,000 RPM on this combination. It wasn't making a lot of power past 6,500, but we did not rev it out to 7,000 RPM. And I know I'm going to get the comment, and I want you guys to make the comment, well, yeah, but the long stroke on the 5.4 limits RPM because, you know, piston speed. Here's my point on piston speed. Piston speed does not limit RPM. I want somebody to show me an application where piston speed actually limits RPM. The reality is that the RPM potential, the absolute RPM potential of almost any motor is always valve train. It's always the valve train that limits it. It's not the piston speed. Do calculations on a modern mountain motor or a pro stock motor or any of these other combinations where they use lots of displacement. I know on the pro stock they use mostly bore, which is a good idea because they get more head flow. But look at some of these mountain motors and you'll see that the piston speed is just ridiculous. It used to be that people thought, okay, well, this is our absolute piston speed. And then they tried a little more and they go, okay, no, this is our absolute piston speed and this is our absolute piston speed. And pretty soon they just stopped calculating. And I remember having a conversation with John Causey, talking to him about some of the motors that he built, and he said, yeah, we just stopped doing the calculation because it always worried us and it never had any effect on anything as long as we could get the motor to rev. And if you look years back in the Formula One stuff, you can see that some of the test motors, they ran to 20,000 RPM and they never changed the bore and stroke because that wasn't the problem. The problem was two things. First of all, obviously the valve train getting the thing to be able to rev at that RPM, because once you get to that level of power production, basically you have a specific torque output that you can reach. It's really hard to get more than that, but what you do is take that specific torque output and shift it higher in the RPM range. If you can get the motor to make that much torque at a little bit higher RPM, you will increase the power output, and then you do that. Once you get that working, everything works out and you make more power, and that's why eventually Formula One said, hey, guess what, we're going to put a limit on maximum available RPM, like they're trying to control costs in Formula One racing, which is ridiculous. But I digress. This 5.4 liter we ran with a number of different intakes to kind of show you what the change in the curve was, and we started out with the factory long runner Navigator intake, and equipped with the Navigator intake, our 5.4 liter produced 426 horsepower and 411 foot-pounds of torque. So now let's take a look at some of the modifications, the other intake manifolds that we ran on this 5.4 liter. Our first intake came from the guys at Carcraft. If you look back at the previous video, I'll go ahead and post up a link here. It's right here. If you look at the video we ran on the 4.6 liter, Carcraft made adapters that allowed us to install
5-liter Ford intake manifolds on the 4.6-liter 4-valve motor. They also made this upper intake replacement basically for the Navigator intake. The Navigator intake was a 2-piece intake manifold, and removing the upper portion of it, they allowed you to install this upper piece and actually put a carburetor on it, which was kind of an interesting deal. So we ran that combination with a Holley 750 carburetor on it. And here's what happened when we installed the Carcraft piece on the Navigator lower portion. As expected, and you've come to see this, when we shorten the runner length, we usually pick up power at the top and lose power down low. And as you can see at the bottom, we lost quite a bit of torque, like 60 or 70 foot-pounds, which is a ton. But we also gained power at the top. It picked up from 424 to 448, so 24, 25 horsepower at the top, but we did trade a lot down low. As you can see, the Navigator intake works fairly good on the Navigator motor, although it would be cool to see kind of a dual runner deal that would provide the best of both of these curves. Obviously, that would be kind of the ideal situation. But here's what happens when you normally, and obviously carburation played a little bit of a part in this, not much, although given the shorter runners, the signal's not great down here. So maybe a little bit of tuning could get some of that back, but most of this runner length, as we've always seen. Let's get to our next manifold. The next intake we ran on the 5.4 liter was also a factory 5.4 liter 4-valve intake manifold, albeit a very rare, desirable, and expensive unit. Most 5.4 liter 4-valve guys probably recognize the phrase or term Cobra R, and the Cobra R was a limited edition deal. And this intake actually is a Boss 290, which is very similar to the Cobra R, although it's a factory intake used on the 5.4 liter stuff down in Australia. So shout out to the guys down in Australia. You guys got a lot of cool, awesome stuff there, including this Boss 290 intake, which in my opinion, probably the best factory intake, 5.4 liter 4-valve intake ever made. Although I would like to change one thing about it and make it more like the Cobra R. I would like a bigger throttle opening and maybe a front throttle opening, although we can certainly make our own upper intake manifolds for these, which I did on the Cobra R, and I'll be showing you. I'll show you, check out a photo of this that I made. Unfortunately, I ran that Cobra R intake on a different 5.4 liter, so I can't compare it directly to any of these other manifolds, including the Boss 290, which would be a cool kind of comparison. But our Boss 290, I was able to borrow and use for this testing because it's quite expensive and quite valuable here in the United States. But as you can see, is a cross-ram style intake manifold. It has even runner lengths, which I like, and we're going to kind of compare that to the Sullivan intake, which I'm going to run next. This Boss 290 intake we ran with the Boss 290 upper intake manifold, but I did not have a factory throttle body for it. So what I did instead was I just vice gripped an 80 millimeter LS throttle body to the flange opening. They obviously didn't want me drilling holes in the factory upper Boss 290 intake manifold because, as I said, it's very rare and very desirable. But here's what happened when we ran it with that Boss 290 with my custom Super Richie LS adapter. So go to our Boss, and as you can see, like the other short runner Carcraft intake, the Boss also lost power down low, lost quite a bit of torque, about 35 foot-pounds, but picked up quite a bit of power at the top. In fact, it made the same power as the factory Navigator intake from 4,000 to 4,500 and then started making more power. It ended up making 459 horsepower, and this is one of the manifolds I wish that we would have continued to run out past 6,500 or 6,600 RPM. I wanted to kind of see how bad the fall off was on the Navigator manifold versus how well these things kind of carried out in that Boss manifold with the runner length that it had. It was kind of optimized for this power range, so I wish I would have continued to run it. But now let's take a look and see what happened when we ran the single plane Sullivan intake. After running the Boss 290 intake, we stepped up to the single plane Sullivan intake, and much like when we ran it with on the 4.6 liter 4-valve, it is a single plane intake. We ran it with a 4150 4-hole throttle body, and we ran it fuel injected, although like with the 4.6 test, if we ran a carburetor on this, it would make a little bit more power, certainly at the top. Here's what happened when we ran the single plane Sullivan intake. As you can see, short runner, again, lost power down low, picked up power at the top, and again, this is one of them I wish I would have continued to run. This thing made 462 horsepower, and it seemed like the curve was kind of still climbing past the 6,600 RPM mark. Again, that's on me. But lost power all the way up to 5,600, 5,650, and then transitioned over. So again, if you were going to run this thing at high RPM with lots of cam on this 5.4 liter, although remember the piston speed is going to limit you. It's not really. But this Sullivan intake, single plane intake, and I'm going to show you an interesting comparison. Let's take a look at the Boss intake compared to the Sullivan intake. So the Boss intake is in green. As a matter of fact, I'll get rid of the Navigator one so you can kind of just compare the two. Look at the blue and the red. This is the red is the Boss intake and the blue is the Sullivan intake. They both make about the same peak power, but the extra runner length in the Boss allows it to make more average power through most of the curve. And the other thing I like about the Boss intake compared to the single plane intake is that we have even runner lengths. All the runner lengths are the same, which means that all the cylinders are producing the same amount of power and they're designed to run in the same RPM range. So let's get to now the adjustable intake. The final intake run on this 5.4 liter 4-valve was my dual plenum adjustable fabricated manifold. It's the same manifold I ran on the 4.6 liter 4-valve motor, and the reason I could run it on both of these motors, the 4.6 and the 5.4, despite the fact that there's a big difference in deck height on these two combinations, is that this manifold was two pieces. It basically just bolts onto one side and bolts onto the other and connects with a common cross tube that I can adjust the length of. So it's easy fit for both applications, and I ran this with, like with the 4.6, in a variety of different runner lengths, ranging from about 11 inches up to 20 inches. So I'll show you these different combinations. Here's our 20-inch runner length. So as you can see, the 20-inch runner length basically made more torque even than the long runner Navigator intake and made more peak power. It made 443 horsepower. Torque was all the way up at 442 foot-pounds of torque. So the torque and horsepower were kind of even. There was a little bit of loss down here in the 3,000 RPM range. Now let's take a look and see what happened when we shorten it down to 16 inches. 16.1. As you can see, 16 is the red now. It loses power down low because of the shorter runner length, and it picks up power up at the top, although at the very top, because we have sine waves happening here with runner length, they kind of converge together. But it made 449 horsepower. Peak torque checked in at 439 foot-pounds. So let's see what happened when we shortened it even more by 2 inches to 14 inches. 14.4. Again, same thing. As we see, we're losing power as we step down in runner length. We're losing torque down low, and we lost torque, as a matter of fact, basically all the way out. Only here, compared to the 16-inch runner length, the crossover was 56 or 5,700 RPM. Equipped with that shorter runner length, it made 456 horsepower, but kind of lost out to the 16-inch runner length through the rest of the curve. So let's see what happens when we go even shorter. We're going to go down to an 11-inch runner length. The 11-inch runner length made the most peak power, although not by a lot, 464 horsepower. But again, just lost power kind of everywhere else. So as we shorten the runner length, we're not really picking up a great deal of power unless we wanted to rev this thing out. But again, given the camshaft, the cams that we were running in this thing, we were still kind of limited on power. I don't think that this thing would have continued to go out any farther. So here's what happens when you change runner length. That's why we select the optimum runner length that gives us the best combination of the thing that we want. And you can choose which runner length you want. And that was the beauty of this adjustable manifold. Let's get to our conclusion.
Okay, 5.4 liter 4-valve owners, what did you guys think about our super intake shootout? Which one was your favorite? Which one would you choose? The Navigator, the modified Navigator, the Boss 290? Everybody should pick the Boss 290 because it is the coolest thing. What about the single plane intake or maybe the adjustable intake? But here's what I think about the Boss 290. I really think it's awesome, and you guys in Australia you. You guys get some of the coolest stuff. That Boss 290 intake, I know it was fairly rare even down there, but it's even more rare in the United States, and we hardly ever get to see them. This one was borrowed, and I had to give it back immediately. I had to sign documents to say that I wouldn't damage it or anything. But here's what I like about the 290. I like it's a cross ram design. I like that all the runners are even, so they're all producing the same power at the same RPM range. Here's the one thing that I'd like to change about that Boss manifold. I'd like to see a bigger throttle body opening, or what would be really cool is to have an 80 or 90 millimeter throttle opening on each side, a dual throttle inlet, or maybe even a front throttle inlet that would allow a big oval throttle body. But I think the dual throttle inlet is definitely the way to go, because then you could have 2 turbos, one feeding each one of the throttle bodies, and that would be awesome. Let me know what you guys think. Which one would you guys pick? Armature holder guys, make sure to like, share, subscribe, ring the bell, do all that stuff. More and more testing every day coming up.